There we go. So yeah, thanks again for joining us for our seminar. Muthu just put all the information you need for upcoming seminars and recording of this seminar in the chat, so check that out. Follow us on LinkedIn. And without any further ado, I would just briefly introduce our speakers today. We have Alex Meldem with us from Flyability, as well as MacKinnon from Unmanned Aerial Services out of Canada. And as I mentioned before, those two folks are probably one of the most experienced in the world of underground drone flying. And I think we are in for a pretty cool talk. So it's not going to be just standard PowerPoint. So I think it's going to be a cool presentation. So with that, I think Alex is going to start, and yeah, take it away, Alex. Thanks so much for joining us today.
Okay, I think I'm unmuted. Sorry about that. I couldn't find the control thing for Zoom anymore. Anyway, hi everybody. Really excited to be here today. My name is Alex. I'm Vice President of Sales for Flyability. If you don't know about us, we manufacture that drone you see right there, the Ilios drone. It's one of its kind, and it's designed to go in subterranean environments and confined space. So I'll get to that in a second. Today we're going to look at this from two aspects. First, I'm going to take a tiny bit of time to talk about the technology itself and what goes into developing a drone for that type of environment. And I'll leave the vast majority of the time to Matt, who is the most experienced pilot in subterranean environments, probably in the world, and his company is the leading company in that type of service. What are we talking about today? After Professor Nagakawa, all I could think about was this. We're not quite there yet, but hopefully in a few years from now we will be with his program and our technology. Hopefully we'll see each other up there soon. A few words about Flyability. We're a pretty unique company in the sense that we are attacking a niche of an industry that is mainly focused on outdoor drones from a pretty unique angle, which is that of collision tolerance and flight in confined spaces. We have one very clear goal, and that's no more humans doing dangerous jobs. Pretty vast indeed, but we're targeting three main work environments. One being confined spaces, the other being work at heights, and the last one work in hazardous environments. Could be a radioactive environment or an area with toxic dust and things like that. In terms of company, we were founded in 2016 after the Hiroshima incident, where basically they were trying to get into that nuclear power plant, but Fukushima, sorry. They weren't able to get in, with ground robots because of all the rubble. They weren't able to walk in because of the radiation. So drone was the right solution to the situation, and that was really the inception of this technology that we're distributing today. We were students at the EPFL at the time, but today we're a team of 100 people. We have about 1,000 drones out on the field to 400 customers across the globe, and we have a pretty robust network of resellers and partners who can, sell and distribute and train and all that. We work in a lot of different industries, ranging from oil and gas to public safety and power generation, chemicals, mining. All these industries have areas where you'd rather not send people in, and that's where we hope to help. Our clients are either large service providers, companies like Matt's, or asset owners who have an internal drone department. Talking about indoor drones, they're very interesting technology. And before I get in the midst of it, I want to remind you, it's still a pretty new and novel technology. And I got a reminder of that a few months ago, right around here at Edgar Mine. You probably won't recognize where this picture was taken because it was in in Edgar Mine, where nobody's supposed to climb up there. I was fortunate enough to, on my second flight in that area, get my drone stuck. The drone with which I took the picture of that drone also got stuck right next to it. That one I managed to dislodge and get back. The other one I now have in my possession again, but it is completely destroyed. Now, why use a drone for inspection in confined space or things like that? It's basically the same value proposition as any robotic solution. We're gonna make the operation safer altogether. You're not sending somebody in confined space or in an area at risk of collapsing or anything like that. We're going to reduce downtime because you're not sending people in. There's much less equipment needed and much less time needed to actually get the job done. Of course, that all factors in lowering the cost. You don't need access installation or anything like that. You'll just be able to fly in and out, making everything much faster and cheaper. If we just look at this in terms of actual facts, I would say From a safety standpoint, you know, I don't know if you're familiar with this chart. I'm guessing you are. The hierarchy of hazard controls. Essentially, it classifies different means of controlling hazards from least effective to most effective, with the measures we have today being the least effective, and the use of a robotic device being, well, the most effective because you're eliminating the risk entirely. You're not putting the person in the confined space or the dangerous area. In terms of duration, and this example might not necessarily be the most noteworthy for your industry, but just to give you an idea, for a 500 megawatt coal-fired boiler, a classic inspection today, excluding the time needed to perform the maintenance, is going to take about 11 days. You're going to need a few days to cool the asset down to a temperature at which people can enter. You'll then have your crew go in, set up a scaffold. Your inspection team come in, do the whole inspection, and scaffold take them down. It's going to take 11 days. With our drone, we can shave that down to about 3 days because you still need to cool it down a little bit when you get 120 to fly in there. But the inspection time itself is much smaller, and of course, you don't need to set up scaffolding, making the whole thing much shorter, and that has a significant impact on cost, where the cost of this 500 megawatt coal-fired boiler inspection is going to cost over $500,000 using the traditional method. Will be shaved down to about $100,000 using the drone, and that's because we don't have the scaffolding and we have a much shorter downtime. There's a lot of other examples of how our drone can benefit a variety of industries. I'm going to skip over those because the main focus today is your industry. So diving into the indoor drone and how we got to a point to build a technology that is able of going into these spaces. There was a lot of different aspects that went into doing this. It may look like a drone and a ball, and it's far more than that. We had to create basically a new system virtually from A to Z to make sure that it was as proficient as it could be to navigating these environments that are dark, that don't have GPS, that may have a lot of dust or other particles floating around. And there were a lot of challenges that went into that, and I'll get to in just a second. Before I get any further, just want to remind you all, teamwork makes the dream work. It's a cliche in our industry, but drones really are a tool in a toolbox. While one drone can do one job, another can do another, and they're usually complementary of each other, as you're going to see with Matt very soon. And now, just to give you a bit of insight on, what goes into designing this technology for these environments. Well, the first aspect we had to consider was collision resilience. We designed this to go in confined spaces, and one of the main aspects of that is that the drone needed to be able to bump into things and stay airborne. There are a few different things we did to make it possible. Obviously, the cage, that's a pretty self-explanatory one. What you were seeing demonstrated here are the motors. These motors can switch direction, speed of rotation in a split second, enabling the drone to stabilize itself in case of a collision, and they were particularly designed for this drone. We then have the whole payload built in a way where even in case of a full speed frontal collision, your drone is not going to fall out of the sky or anything like that. The payload is going to retract into the cage, pop back out once the collision is over. You might see a few zip ties falling out. That's part of the design. Essentially, the cage is going to be, the zip ties will be the first part of the cage to sacrifice so that it can deform a little bit to keep everything safe inside. And it usually works pretty well. Now, in terms of size, we're trying to fit in confined spaces, so we had to be able to fit anywhere where a person could slip through. So we made this drone to measure 15.7 inches across. In most cases, that is amply sufficient to fit through any space or a standard size manhole. One of the main challenges in designing this drone is that we don't have GPS. As you know very well, inside the mine, you can't really access GPS signal or anything like that. So we still needed to create something that was not only an aircraft for the most proficient pilots, but also just a tool that engineers could pick up and use to go get data when and where they needed to. In order to do that, we try to figure out a way to keep the drone stable without that GPS signal, and our solution is using a series of optic flow sensors, which are essentially going to send a signal out, and which is going to bounce back against the nearest surface, come back into the sensor, and then inform the drone where it is in terms of a distance to the surface. And with that information, it's going to be able to keep stable. Not trying to oversell anything here. There are situations where these don't work in large spaces. These sensors do have limitations. Again, it's a new technology and we have limitations here. But in most cases, this feature allows you to basically let go of the controller and have the drone hover in place. Of course, at the end of the day, regardless how fancy the drone is and regardless all the feature it has, the most important thing it can do is collect data. It's a very fancy flying camera. And so we had to make sure that the lens we had on there was optimal for what we were doing. So we have a 4K camera that's capable of taking 12 megapixel stills, but it's also a fisheye lens, which is pretty unique in the industry because the situational awareness component of flying in a subterranean environment is so much more important than when you're flying outside. outside, above you, beneath you, behind you, and all sides, you'll have air. In a confined space or in a mine, you have things all around you that you need to be aware of all the time. We can expand the view just a little bit with this fisheye lens, and that makes a world of difference in terms of knowing where you are while you're flying. We also have a thermal camera on there. It's really good for detecting steam leaks and water leaks and things like that, faulty installation. It's a particularly useful feature for the nuclear industry, and it was one of the main drivers to implement this because they need to know exactly where steam leaks are located, and they're able to do so with this payload. The camera itself can tilt all the way up and all the way down, which is not necessarily something you'll find on most drones. It's really important when you're flying in an indoor environment, though, again, because the situational awareness component of flying in an indoor environment is everything. If you don't know what's above you or what's beneath you, there is no way you can move around as needed and perform your inspection. This is just a video demonstration of the quality of the camera, but Matt's going to have plenty of those in just a minute. And then lighting. So lighting is it was a particularly interesting challenge in developing these drones because the places we go into have no light. We had to figure out a way to bring light inside, bring in such a way that if we were flying particularly dusty environments, which is often the case in mines, we can not pick up on that dust too much and not have that snowy effect to maintain situational awareness and for the quality of the data. And finally, this lighting system also needed to have a few features. I'm about to get to them. So the first thing we did was the lighting, selective lighting to avoid picking up on the dust. And you see it demonstrated here. Essentially, the right image is full light coming in from the frontal lighting system, whereas on the left, it's the side panel shooting light to both sides so the camera doesn't pick up on the dust. And that was a really big factor in making this drone, easier to fly, but also making sure that the data that it produces is high enough quality to be used for inspection purposes. We also added oblique lighting features, maybe not quite as relevant in the mining world, although I don't quite know, maybe Matt can tell me more about that. But essentially the idea here was to replicate exactly what inspectors do in their, when they're in an asset with a flashlight shining at an angle on the surface to see if there are any crack, pits or bumps or things like that. Exactly the same concept here, but only mounted on the drone. So as you can see in the right and the left image, it's facing straight to it with direct lighting. On the right image, we've got that side oblique lighting methodology, and then here you start seeing those pits show up. And now, quickly before I finish up, the data. Data is really at the at the key, the heart of everything here. Again, it's at the end of the day, it's really not about the drone. It's about what data you can get from it, and we put a lot of thought into how we would manage the data. Again, we don't have GPS, so you don't have the usual feature of being able to geolocate the data using a GPS signal. So we had to come up with a few different things here. The first one is, well, with these sensors, that's pretty straightforward. Since we can know the distance in front of us, we can perform 2D measurements. And those are done in our software. You also have the ability to build 3D models using the data you gather from the drone, and Matt's going to expand on that way further, so I'll keep from it for now. And finally, this is a brand new feature that is very exciting for us. What we did here is basically within our post-processing software, added the VIO data from the drone and use it to process it in a way that allows us to create a sparse point cloud of the asset in which we've flown. And basically, it's a very meager replacement, I would say, of the GPS, of the ability to have GPS. So what this will do is basically just map the inside of the asset, the mine, or whatever, so that you can locate any points of interest that you found while flying. You'll be able to pin those within this map that you've created using the VIO off of the drone. And then it'll also track the flight path and give you distance information. Still very early on in terms of release. We released in November. We're running the beta program now, so we don't have tons of information yet on how accurate the data is, but hopefully we'll be coming out with more of that soon. And with all that being said, I think I've told you enough about how we get around to creating these drones. And I'm going to stop my screen and let Matt take over from here. Thank you.
Perfect. Hello, everybody. Yeah, so I'm going to take a little bit of a different approach to this webinar than most webinars, I guess, that people have been taking. So I'm not going to do the traditional PowerPoint. I'll just kind of go through an introduction of my company. And I have some videos that we put together of just inspections that we've done over the last 3 years, some successes as well as a couple of challenges that we've faced throughout it. And it's just a variety of different mine sites that we've been at, whether it's a production mine, mine that's been in care and maintenance, or mines that they're trying to get back into. And so it'll be a little bit of all of the above. So once again, I'll introduce myself. I'm Matt MacKinnon. I'm the founder of Unmanned Aerial Services. We were the world's first full-time drone inspection company for underground. We were the first early adopters of the Helios for regular use in underground mines, as well as with the Emacent hover map system, which is the laser mapping system that we use, and then you'll see some examples of in the videos coming up. So we started this company about 4 years ago in Sudbury, Ontario. And Lucas, if you want to start up the video, we'll kind of show you why we went underground and why drones are important.
7:35 stow flight 1, August 31st, 2018.
All these videos are going to be sped up, and I'll be able to talk over them. This was a testing flight. We were running a sensor that the manufacturer essentially wanted us to try to run. And we were getting ready to enter into the stope to go do our testing flight, and I'll let the video kind of show the rest.
Got a video, right?
So that was pretty much not the reason we started the company. The company was up and going in 2017, long before this video was recorded. But it just kind of captures the type of environment that we're dealing with and just how quickly the environment can change. So being able to put a remote system into these areas to map it also reduces the risk to the equipment over a traditional CMS, where you park it in one, essentially you have it in one specific spot and it's sitting there, and there's a higher chance of something going down than it may hit it, especially at the brow. Where with drone technology, you're able to freely fly around the environment. So it allows you, in my opinion anyways, it lowers the risk of stuff going wrong, because the chance of being in that area where the bench comes down, because 20 feet beyond that, there was no material that was coming down. So it's just a matter of timing, but really highlights the hazards underground. And I guess Alex or Lucas, if you want to queue up the rest of the videos, hopefully they play fine, but we'll see. And then after this, I'll kind of walk through some of them, and then I'm going to leave it open to Q&A to everybody. Anybody who has any questions and wants anything answered. So it's a pretty typical mine that we'd go into that would be either in care and maintenance, or they'd be wanting to get back into after it's been closed down for a number of years. And this just kind of highlights the type of areas that anybody who's involved in the mining world is kind of aware that it's extremely hazardous to be able to go up to this area. Knowing that there's open holes that could be anywhere. When you have wall-to-wall material and muck that's on the floor like that, mud, anywhere can be an open hole that you can potentially fall into. So for a lot of these mining operations, to be able to safely access these areas, it allows them, number one, to gain a bunch of information safely in an area that is unknown. And number two, they're able to go back at the end of the day or after the flight. We can review all this footage and formulate a plan of how they're going to get into these areas if they'd like to get back in to rehabilitate them or whatever the case is. I wish Zoom was able to have the videos play a little bit smoother, but hopefully this is coming through on everybody's screen. But this is just some typical areas that we regularly operate in. But the one thing that I hope is coming through on these videos is just the range and how far we're able to go away from the operator. And all this is done without the range extender. So Flyability was was proactive in creating a range extender and being able to have that option available. So when you come into areas like this where you need to get the extra range, but you can't physically actually get yourself and the controller, being able to throw the range extender out or put it on a buggy and drive it out, or on a cart and push it out, gives you the ability to extend your range that much further. Plus, it gives you the ability to you can add a back plane to it to essentially make it almost a directional antenna, which also then increases your range to allow you to get into these areas to get the information. And this one here is a video that really highlights one of my head pilots here at our Sudbury office's skills. He was out at a remote site, and this is some old workings. I'm not sure the date. It was probably the 40s, 50s, maybe a little bit later, but none of the bolts were holding any of the screen anymore, and it was essentially a maze for our pilot to be able to get through. And it's quite amazing that he was able to get it through all this stuff and be able to get it back safely. And that's the benefit that Alex was talking about earlier of having the cage the way it's designed, with the footprint that it is, with the 16-inch design. You'll see some videos a little bit later on in this that things don't go exactly as planned. The flight isn't as smooth as this, and we have material come down on the drone in certain ore passes and bins. So having that cage and being able to take an impact where any other drone, whether it be open propped or traditional prop guard, would be essentially destroyed. Being able to have the cage around you gives you the extra resilience to take a decent enough blow and still have the drone steady itself, which Alex showed a great example of with the test of it tipping over. So when you're taking a lot of material coming down onto your drone, it's nice to know you have that cage and you have a lot of really good engineering and testing that went into it that's able to get you in and out of the areas. This video here is just a great example of a client, just regular routine inspection. They were pulling the bin down. They just were planning for maintenance, wanted to see how much accretion and buildup there was. While we were in there, we were flying down into the chutes to try to inspect the plates and liners. And you can see they expected everything to look like the last example where all the plates were installed, but instead they found a huge gaping hole. Here's another great example for anybody in the mining industry who knows that you do not go into any equipment without locking and tagging. This particular video, just the timing, the way everything worked out is there was very little downtime in between when they had the crusher empty. And essentially they had pulled basically the last of the material out and gave us the green light to go in. And if you actually look up, you can see, I don't know if it'll come through in the video, but you can actually see the crusher still moving. So there's no way you'd ever conduct an inspection, obviously, with the equipment still operating. However, with the Helios drone, you're able to stand well back of the feed chute and still be able to conduct an inspection and identify any potentially missing plates or liners. Here is a great example of when stuff doesn't exactly quite go as planned. So in this one, unfortunately, if you can see the little hook that's sitting there, you'll see in a second, our pilot isn't able to go any further. And unfortunately, that's because he got hooked on that little hook. During this all, he was right at the edge of his radio link. So his radio was coming in and out, or his video. He still had command and control, but he was trying to unhook himself, essentially blind. So kudos to him. He actually managed to unhook himself and then ended up getting wedged again for a second time. So now he's actually way up in the back and has lost all video. And he's essentially just flying off of memory right now, just remembering that he got himself up there, the lay of the land, and that there was that hook and the plate there. and manages to somehow get himself unhooked and manages to fly back. Here's a great example of the cage and why it's really nice to be able to have that cage. And it's not that we ever rely upon it when we're doing an inspection. It's something that it's kind of a nice to have rather than something that we're utilized during the inspection to bump around. And another perfect example of an inspection being conducted and not interrupting either work downstream of the inspection. So because we're flying in with a robot, there's no major concerns of the inspector being underneath those employees. But here's when it's nice to have the cage. So kudos to Flyability for, like I said, spending the time in the testing. I don't think they ever ran their machine through a rock blender or turned their robot into a rock blender. But we decided that we could test that for them, and here's the result. All 4 props were still intact, and we were able to fly out safely and hand the client over the data.
Just as a quick side note, sorry, a quick side note, we did test it as a rock blender.
Oh, perfect. Well, it definitely passed. Here's a great example of a tethered drop. So sometimes we're asked to do inspections, and this is going back probably back to 2017, 2018, to do vertical inspections. The one limitation with the Helios drone, and almost with every drone, is battery life. So with 10 minutes of usable flight time, you're not going to effectively inspect 1,000, 2,000, 3,000 foot vertical raise. However, if you hook it up to a tether and lower it down, there'll be a lot of mining people in here who will be able to relate to a GoPro spinning wildly on an end of a rope. So instead of having a GoPro spinning wildly on the end of the rope, you can hook up the Helios essentially to it, and you have full control over your direction, your azimuth, and how you're looking, as well as the tilt and your lighting. So there's a lot more you can do with it than just flying. So that's just one other way of deploying it. This is just an example of us, and I'll touch upon it a little bit later, but just the integration of sources. So this is utilizing the hover map, our laser scanner, as well as the Helios to create a photogrammetric model. So you can see the conditions are terrible inside. We're getting dripped on left, right, and center. But to much to our surprise, we were still able to put together a fairly reliable model that scaled properly, and we were able to tell the client essentially where their blockage was. And now we're getting into the MSN technology, and this is the supplementary side. So when we have the opportunity to get into larger areas, and we can get our laser scanner in, this is the results that our clients expect to receive from us during a flight. This is a fully autonomous flight. The lines that you're seeing were the actual flight path of the drone and the waypoints. And there'll be another example of it coming up. This here is just an example of one of our ore pass inspections with our buggy, and I felt as though I wanted to throw this in because it ties in perfectly with the space mining miner. With just the way it looks. There's a lot of similarities when you're operating underground to being in another planet, or at least that's how I would feel being on another planet, where you're just in an inhospitable place where literally the roof can fall on you, the back can come down on you at any moment. So this is just kind of a great example of that type of unknown environment where you have to have everything working properly, much the same as a rocket being sent to another planet. You only get one shot at it. So you have to have everything go right to have a successful mission. But if one single thing goes wrong, you could be losing your ore pass, your buggy down at the bottom of an ore pass. And these are just some more examples of some more autonomous flights. The great thing with the hover map system is it has an onboard GPS denied position hold as well as collision avoidance. If you jump on YouTube, they have a video MSN does of it, basically avoiding and flight planning around a 1mm wire. So it's quite reliable when you're operating in areas where you have no idea what you're seeing. And this is the last video just kind of showing what the client sees versus what we actually see when we're in the field. So we have an amazing geospatial specialist within our office who's able to take environments where you're just dripping water and you're in a complete downpour. And anybody who's involved with laser scanning will know how much noise is introduced by that. And have it cleaned out and have that type of scan delivered to a client is essentially what we do. And that pretty much wraps it up. I hope the video wasn't too long or too fast, but I noticed there's a couple of questions in the chat. So I don't know if Lucas, if you want to kind of ask them out, or if anybody else wants to moderate that, and we'll kind of just answer as many questions as we can in the remaining time.
Yeah, totally. Thanks, Matt. Yeah, let me just say if there's anyone who wants to ask his question, his or her question directly to Matt or Alex, just go ahead and unmute yourself. I think we have a bit of time and got not too many questions, so we always like to have a bit of a discussion and makes it more personal. Otherwise, if there's no one speaking, I'll just go ahead and go through the questions. Well, I guess I'll just read some out. So the first question I got here is from Rich Pratt. He was asking about autonomy. Can you speak a bit about maybe you had the two parts of your video, Helios and Hovermap, where autonomy stands? Maybe Alex can chime in about autonomy for Helios at some point.
Yeah, so as far as autonomy, sorry, excuse me, the Flyability Helios has no autonomy, so it's all pilot control. So we have the sensors that Alex was talking about, the position hold sensors, add a great deal of stability and mobility to the system, but we are still limited to battery life and link with the system. Unfortunately, the fail-safe, there is no return to home. So typically we'll push the system as far as we possibly can when we're coming in a bottom up scenario, because its fail-safe is to come back down, which then it comes back into its signal and we fly out. Top down scenarios, we don't push it quite as hard, because if it doesn't enter into a fail-safe state, it will descend down further away from your radio. On the autonomy side, that's only available with the MSN hover map system currently at the moment. There's other manufacturers that are developing a system. This is the system that over the last 4 years we vetted other systems and very much decided to go with. So on the autonomy, you pretty much just set your waypoints. So you would fire up the drone, it would start building a very basic model. And from that, you could start planning waypoints. So in a traditional stope, you'd be coming in the bottom sill, you would start the drone, or top sill, doesn't really matter. You'd start the drone, start the scanner, you'd get some points, you'd have the void where the stope is, and essentially you can just plot two waypoints, one out over the stope, and then it'll start populating again, and you can send another one, or most people know the stope and the stope design they're going into. You can just plan two waypoints without knowing the environment, and even if you plan the waypoints into a rib or into a wall, it'll actually avoid that and still fly down, get as close to those waypoints as it safely can, and it'll return to home if you don't give it a command within 10 seconds, I believe, after it reaches its last waypoint.
All right, cool, thanks. Maybe kind of in the same realm, Morgan Lane was asking about radio range along a straight path, and then I guess that was referring mostly to the Helios, and then going around corners, what the limitations are there.
Yeah. So what we typically say in a hard rock environment, we will confidently say 500 feet around one blind corner. So that's up into a raise, into a stope. You can extend the range. It truly depends on what you're dealing with. With a high humidity environment with a lot of water vapor in the air, it tends to really degrade the signal. If you have a lot of mesh hanging down, like the one example we had where Jeff was flying through, it almost acts as a Faraday cage depending on how it's sitting. And the same thing with water coming down from a brow. If you have a sheet of water coming down at a brow that you need to fly by, normally in that exact same stope, exact same layout without, or in an ORPAS, we'll use as an example. If you had no water coming down, you'd get the 500 feet or 400 feet, no problem. If you had a sheet of water coming down at that brow, you'll be lucky if you get any more than 40 to 100 feet away, because it just beats up your signal. So really depends on where you're operating and what it's like, but we'll say confidently 500 feet beyond around one hard corner. And then you can start throwing in the range extender, and there's other little tricks that you can do to extend the range. And then essentially for battery life, you get about 10 usable minutes on the Helios, 8 to 10 on an Helios 2. So you could effectively, on a straight drift, fly a kilometer, 1,000 meters out, and come back, but it's more of a shuttle run than an actual inspection. So if you had a mine rescue emergency, and you needed to get into an area and you're more just relying on the thermal data coming back and being able to just see if there's a hot spot or potentially a victim trapped in behind something, you would be able to fly out and come right back for an actual inspection. We'd say less than that, just because you want to be able to have a slow enough and a stable enough image where you can actually visually use it. And then actually, maybe I'll touch upon the hover map system as well. So the limitation on battery is much the same when it depends on the system. So currently they're offering it running on the M210 system and the M300. The M210 fully configured gets about 13 usable minutes of flight time. A typical stope takes around 3 to 6 minutes to map, so more than enough time. And then the much larger platform, the M300 platform, you can actually do essentially a 10-kilometer round trip. So 5 kilometers out, 5 kilometers back, on a set of batteries on one autonomous mission.
Cool, thanks. Got some questions here about, doesn't specify which drones, but regarding temperature limitations of the drone, also water resistance, and how water relates to filming, quality degradation of the video feed. Is that an issue? Yeah, and also strong wind in underground mines caused by ventilation. Those are all kind of the edge cases, I guess, where you want to when you push.
I don't know if they're edge cases. It's pretty
cases, yeah.
It's pretty standard for us. And Alex, feel free to touch upon anything I missed out on the Helios. For the Helios, there's no rated IP rating for it at the moment. So typically we try to fly around the drops. Doesn't happen that well. So no, it's just a lot of care and maintenance. So after every flight, whenever we have a wet mission, we literally tear the drone apart in the shop, make sure that we clean everything out. We put additional safeguards in place to try to help mitigate any water from coming in. But you're pretty much, there is no IP rating, but I wish the video played a little bit better. You can operate in very wet environments, but the manufacturer won't recommend it. On the hover map side, the M210, I believe, and the M300 are IP56. I know they do have an IP rating. We've yet to come into a situation where we've had any of the components get wet inside. The payload itself for the MSN hover map is not IP rated. It is neatly kind of tucked in underneath the drone. So short of flying under a borehole or something else that's just shooting out water, you'll be pretty good. You'll have protection from the drone above. There's a good video on YouTube that MSN actually put up of where they inadvertently put a waypoint right at a borehole, and the drone essentially stops just before that, and you can just watch the water just pouring onto the prop and the drone and splashing the laser scanner. So we recommend that you don't operate in water. However, the reality is that we're operating in an underground environment, and water is present everywhere. So we can't expect you guys to not use the drone when there's water, because you guys wouldn't use it. So it's just, with the system, we recommend anybody who purchases a system to have specific people designated to the system, so there's a level of accountability and responsibility associated with it and tied to it. And that tends to usually work that we've seen. There were people that have a lot of care for their equipment, because it's very much a special job to be able to, essentially you're getting paid to play with toys. They're very expensive toys, but at the end of the day, we're getting to play with some really cool tech. So for that luxury, a little bit of care and maintenance and love goes a long way with the systems.
Yeah, I completely agree with that. Maybe to touch just a bit more on the IP rating, we indeed don't have one. It's a matter of prioritizing, what we had to do first. It's splash proof and dust proof for the most part. We fly it in sewers all the time, and in fact, that one drone that you saw was stuck in that mine, I think, for 4 or 5 months. And while it is in pieces, it's still working perfectly fine despite taking a heavy load of humidity throughout that time. So we can take splashes, but it's definitely not recommended to get anywhere near a body of water with it.
There was a question earlier on touching on battery safety. Is there any concern about battery safety, fire hazard with any of the clients you've been working with so far? Was that a limitation?
No, most of them are pretty receptive to it. We're running lithium polymers, so a lot of the cordless tools that they use underground, the Hiltis, the Milwaukees, the Makitas, they're all running lithium ion or lithium polymer batteries. So there's a certain level of awareness. We've yet to have any real concerns raised, and a lot of the equipment and a lot of the mining now is moving towards electric, and a lot of them have realized that lithium or a variation of that is going to be needed to electrify the mining world. So there's a lot of understanding of it, and the reality is the batteries that we're running are quite small as far as energy density. So if you were to puncture them and they were to swell up and catch on fire, short of being near a mag round or magazine heading, you're going to be okay, to the best of my knowledge, with all the clients that we've dealt with.
Cool. Just a clarification, I think you mentioned the return to home feature in the MSN, but the Ilios doesn't have a return to home feature, right? There was someone asking for that. That's
correct. Yeah. Yeah. If you're flying up into an area, it'll descend back down to you. The Flyability Ilios 2 will. The MSN hover map will do an automatic return to home if it can't reach the waypoint, or if it loses comms and times out, or if it gets or it reaches half battery, or what it perceives as half battery, to come back with a reserve.
Can you speak a bit about the actual data coming from the drone? Specifically, the question was about point cloud data, exporting it into Deswik, MineSight, Point Studios, something like that. Following measurements, is that a pretty straightforward process? What's required there?
Yeah, so with the MSN system, they have actually partnered up, MSN has, with Deswik. So they do have an extension that pretty much interacts directly with the hover map data. Also, Deswik has a LAS extension that you're able to also purchase, where you're able to take the raw point cloud and be able to bring it right into Deswik. So as far as mine viewing softwares, CAD programs, other things like that, we've yet to come across a program that we're not able to get our scans into. It's usually just a matter of subsampling them down for a lot of the different systems, and just changing the extension. The one biggest thing that we're running into, and maybe I'll touch upon in this talk, is just on education on different extension types. Everybody's asking for DXFs, and we're dealing now in just pure 3D data. And DXFs were never designed to handle that or to be for 3D data. So you're seeing these massive scans, or everybody who's asking for a DXF is losing all the detail that we're able to capture with the system. So by turning it into an OBJ, STL, PLY, a lot of the programs out there are now starting to natively support 3D data. And then we're able to put them in those extensions, the same as a DXF or any other thing that anybody needs, and get it into their systems.
Cool. So maybe the spicy question at the end, or not at the end, we got some more specific ones, but how much does it cost to come to site? 1 to 2 days of mapping? I guess that depends on the drone and client, but maybe can you name some numbers there? Or
I can't really throw in numbers specifically, but it really depends on what the client's needs are as far as what equipment they're going to deploy. So we have a different cost tiering for the equipment we deploy. So for the actual, like if we're doing just stope flights, so we have the drone like you see in the background of my wallpaper. If they just needed stope flights, we have a set rate for that. And then it depends on how many stopes they need to have covered. And then we also, if they have ore passes, vent raises, really depends on the application. But if they have a specific site, I believe my email should be in everything, or I'm on LinkedIn. They can send it over with some prints and we can get them a quote over.
good. Was a question from Richard Bishop. Curious about submersible drones. Is that anything you've been working with, Matt? Or
we haven't specifically. Anybody who is interested, I recommend. There's a company based out of Kitchener here in Ontario, Canada. They're called Deep Trekker. I would point you in their direction for any systems that you need for underwater. Alex?
Oh yeah, absolutely agree. The Deep Trekker seems to be the leader by far in that space.
Cool, thanks. Gerardo was asking, what challenges do you see when sites purchase equipment themselves and use it by themselves? You kind of briefly touched on that, and you can give it one example for.
Yeah, I think of the biggest thing is there's a misconception with drones, and a lot of people go into this with the attitude of my 13-year-old cousin, niece's nephew has a drone and it flies so easy out on surface. So when you walk into it and you're dealing with clients that have that kind of mentality, it gets a little difficult to have them understand that there are certain steps in place, and it is a very easy system to fly. Both the Helios as well as the hover map system are extremely easy to fly. Speaking to the Helios too, anybody can fly it. A child can fly it. Not anybody can do an inspection with it. It takes a certain type of individual who's very methodical and can cover the ground in detail and understand overlap. And there's many other nuances to it to effectively be able to do an inspection. So that's the one biggest thing. A lot of people take this and it's like, oh, a drone. We called the company in, they flew it. It took them like 5 minutes. They're in and out, handed us the data. I don't know why we paid them whatever we paid them. Let's just buy a drone. But what they don't realize is that person who came in that did that job in 5 minutes had 150 flights in a similar area under his belt ahead of that, and understood the system, understood the lighting, understood every little component that he needed to not fly over beams that are covered in dust in an old industrial building. It may seem like such a simple thing, but to have that experience and knowledge to not dust everybody out, and not only that, but not dust out your imagery, is something that's learned. You can try to teach it, but it's something that's done in field. So the one biggest thing to it is having end users understand that you have to have, it's like anything. You're not going to grab your janitor and put him on a scoop and expect him to not destroy the scoop or to be able to make the numbers. And it's the same thing with the drone technology. You have to have specific individuals tasked with it for not only the accountability side of it, but just to have them be the best individuals, the best trained and experienced individuals for that task, because stuff can go wrong extremely quickly. Like you've seen in the intro video, he was flying up and like talking with him after, the reason he stopped is because he heard, it won't play in that video, but you can hear two little rocks, essentially two little pieces of ore fall down before that. and he stopped, and then that's when the bench gave way and dropped all that material down. So it's just little things like that, and just not rushing in and knowing the equipment that makes a huge difference to the successful integration. We've seen it with a lot of companies where they go, yeah, we bought a drone, piece of crap, it's sitting on the shelf, and it's that they just didn't have the people who understood the system and understood how to deploy it in the industry and what they needed to do with it.
Yeah, maybe just touch on that a little bit more. It's something we see often. Companies will buy drones and they end up being extremely expensive paperweights. Matt's absolutely right. It takes a certain infrastructure in place to be able to adopt this type of technology. And in fact, most of the people from the mining industry who come to me end up in Matt's hands, because I think most of the time I'm convinced they're better off getting a service from somebody who knows what they're doing versus doing it themselves. Like Matt was saying, flying the drone itself is easy. The environment in which you're flying is extremely complex and has tons of different challenges to operating a drone. So you need somebody with the proper experience who's willing to put the hours in to get the skills and the training necessary to fly in that environment. And then, like you were saying, you also need somebody who'll be willing to take on the task of maintaining this device. It's a tool, and like any other, it takes maintenance and it takes a bit of tender love and care. And you need somebody who's dedicated to that. So, you know, we don't quite, I wouldn't say we vet our clients, but especially in the mining industry, in a lot of occasions, I'll end up referring them to Matt, because it doesn't seem like they have the infrastructure in place to use it on their own.
Thanks. Yeah, we're just right at 5 at the moment. We got 1-2 more questions going. Just for everyone still in the talk, thank you so much for joining. We're gonna hopefully make the recording available if you want to refer it to someone later. Next week, we're not gonna have a seminar because of the SME conference, but we'll be right back the week after with a cool topic on artificial intelligence in mining. Basically, the top guy at Vale is going to speak to us about that. And Muthu, if you're still online, you can maybe put in the link to the LinkedIn event. And if you want to sign up already, that would be awesome. Pretty cool talk as well. With that, if you guys are still good to be on for a minute and answer a question, that would be awesome. Otherwise, thank you so much for the talk. I think it was really cool, especially with this non-PowerPoint approach. Not blaming you, Alex. I think you did a pretty stellar job too.
No, it's fine. Thanks, Lucas.
But yeah, having that mix of video and PowerPoint, and then also the deep expertise you both bring to the table is just awesome. Thank you so much for that. And yeah, just one more question. I think the last one was covered pretty well. About pretty specific losing signal, and then is there a way to track that signal back to a specific location? I guess in the case of recovering a drone, is any type of work you did before trying to track a signal? I'm not exactly sure if the question is.
No, what I think they're wondering is just on connectivity as far as the system. So for the Helios, so none of the systems work on leaky feeder. There's not enough bandwidth. For the Ethernet, at this particular moment, I don't think, well, you could add additional components on and make the Helios connected into an LTE network or a Wi-Fi network. Conceivably, all drones could do it. It would be a lot of fin dangling, and it's not something that Flyability is working on, I don't believe, or is, or will be. The hover map system, yes, you can tap into it with Wi-Fi, LTE, 5G, any of those. We did a test, actually, the world's first remote teleop with the manufacturers with Emacent. They operated the drone from Australia. We were in Timmins at the Kidd Creek operation. I believe it was down at the 3600 or 4600 shop, and we successfully piloted the drone, so gave the autonomous waypoints and flew the drone from Australia, with the drone being located in a mine underground. So yeah, you can absolutely tap it in. It's a lot more, there's a lot more to it. You're just not going to pull out the drone, set it down, and just connect to it. But yeah, that is where the progression is going towards. We're taking miners away from the face and having these drones where you can have them. So if you have a seismic event, mine emergency, anything like that, you can potentially have them staged in areas where you can connect to it up from the control room at surface and basically command the drone, much the same as some of the different systems on surface like Percepto, Arion, them, who do drone in the box solutions, but for underground.
Oh, perfect. Yeah, with that, I think we're done with the questions. Thank you so much again, everyone, for joining, and thanks especially to Matt and Alex taking the time. And that concludes the seminar for this time.